Hi guys, welcome to my channel. This is the 30-day lead code challenge for the month for April 1st, 2020. Today, I started off late, but I would do all the weeks, and I'm gonna upload it as soon as possible. So the first problem that I would go around is, sorry, the single number. What it basically is, you're given a list of integers, and all you need to find is one occurrence of one element. That is, only one element one element appears only once. The rest of the elements appear twice, and you have to find that element. So, he's pretty much saying you should have a linear complexity and stuff like that. The reason he's trying to do is you should not be sorting it. That's why he's saying it's a linear complexity and don't do binary searches and stuff like that. It's a pretty much straightforward algorithm. All you need to do is to XOR all the values. The moment you XOR all the elements which are the same, like 1 and 1 becomes 0, and if there is any element which is not the same as the other, like in this case 4, there's only one occurrence. The 4 value, when it's XORed with 0, it becomes 4. So all these values, 1 and 1 becomes 0, 2 and 2 becomes 0, 0 XOR 0 is 0, but 4 XOR 0 is 4. So that's why you would be left with 4. So this is a very, very straightforward solution. A lot of people have done this. Some people do left pointer, right pointer solutions, which is also not bad. However, I didn't bother doing it, and I felt this is a very, very simple and straightforward solution for it. I'll run this very quickly. And I submit the solution. So pretty much loop through every element and XOR it, and at the end you'll find your value which is not the same. So it's been accepted. So this is what the solution is. I've done a detailed video of if it's sorted, then how do you do binary search and stuff like that. So this is a very, very straightforward problems which you can do it very quickly like this. The next one is happy number. The problem happy number is basically you're given a number like this. Every single digit you square it and you get the sum of it. And as you're going through in this loop, you have to end up with 1. If there is 1, then it's a happy number, and if you don't get 1, you go on in an infinite loop, like this guy says loops endlessly in a cycle. But since you're running Java and there's a Stack Overflow, you pretty much pick the higher limit. So I picked 10,000. Beyond 10,000 for me is infinite. So I said beyond anything about more than 10,000 iterations, just return false. If not, if there is 1, then return true. This is how I have formulated the problem. So pretty much what I did here is happy calls a recursive function happy number. So and I pass in the number which is given to me, and then 0 is the number of turns. Like I need to count number of turns. If there are 10,000 turns, then I stop. So I need to remember the turn. So the first time I call this function, the turn is 0. So here I check if the number is 1, then return true. I don't even have to go beyond. If I go beyond 10,000, as mentioned in this problem, you don't want to go endlessly because you're going to get a Stack Overflow. I picked 10,000. If my turn is greater than 10,000, I return false. If not, what I did is I took the number and I created a string, and I started taking each character from that string, and I squared it and I summed it. So instead of doing divide by tens and all that, I felt this is much simpler, wherein you pick up each character and pass it into an integer, square it, and build the sum. And then again pass the same sum and turn +1 to the recursive function. If the sum is anytime 1, then it's going to return true. If you go past 10,000, it's going to return false. I felt this is a pretty straightforward solution like this. And I'm going to run this code. So that's the status, and then I submit it. So that's been accepted. The next one is maximum subarray. The maximum subarray, I just did the Candian's algorithm. I didn't even want to go beyond Candian's algorithm because that's a pretty much straightforward thing. What it basically is you have to find contiguous elements which have the maximum subarray. So I didn't do the divide and conquer approach as this has been asked for because I felt it's a very straightforward solution, and actually doing divide and conquer is a little bit more complicated. Um, what it basically is you have a global sum that is 0 and the current sum. So you're trying to find the current sum. So if your current sum is more than the is your current sum and the number that you're trying to uh, the current sum plus the number and the current number. So this can be negative. So if you're trying to add a negative number to your max current, it's going to reduce your max current. So that's the reason you're going to get the max of these two, and that's going to be a max current. And if this max current is less than a max global, update the max global. That way you're going to find the maximum global value. This is a very straightforward algorithm. Candians, everybody has done it. You can look at it in the internet. There is a lot of explanations on Candians. So I pretty much picked the same solution here, and I'm running this code and submit. And the next one is move zeros. Sorry. Oh my god, sorry. Um, in this so there is an input array and there is an output array. All you need to do here is sorry, there is an input array, and in this input array you're given a list of numbers. All you need to do is move all the non-zero numbers in the same order and zeros at the end. So you have to do it in place. You can't create a new array, and you have to minimize the total number of operations. I picked a two-pointer solution for this, that is a left pointer and a right pointer. So if I find my left pointer value is a non-zero value, which is how this is supposed to be, I keep incrementing it. If I find my right pointer as 0, I keep decrementing it. So I need to find all the numbers in the middle which need to be rearranged. And if my left pointer is 0 and my right pointer is not 0, so in this case my left pointer is 0 and my right pointer is not 0. So what I do is I move everything, and the 0 goes to the end. So I literally move all the elements from the left pointer to the right pointer. I move everything, I shift everything to the left. That way 0 goes to the end. So this is a very straightforward algorithm. So this is what I've done. So my left pointer is 0, my right pointer is the end of the array, and my left pointer should always be less than my right pointer. If my left pointer is not 0, I keep incrementing to the right. If my right pointer is 0, which is what I want, so I keep decrementing to my left. So if my left pointer turns out to be 0 and my right pointer is not 0 in this case, then I start moving them. So I literally rotate the array so that I move all the elements from my left pointer to the left, and whatever is left, my last entry of my right pointer is 0 is what I'm trying to move. So it's a pretty straightforward two-pointer solution. So I'm running this code. And the status is finished, and then submit. Okay, and then the next one is best time to buy and sell. So this is a second type. There are many types of best time to buy and sell. So this is the second solution wherein you can do any number of transactions. You may complete as many transactions as you like. So all you need to do is you're given the price on each day, and you need to maximize the profit. That's what it says. So you can buy if you buy on the 7th, on the day 1 you're not maximizing any profit, so you're not buying on this day. So you buy on day 2, which is 1, whereas the price is 1, and then you sell on day 3, so that the value of that is going to be, the profit is going to be 4, and then you buy on day 4, and then you sell it on day 5. So your total profit is 4 plus 3, 7. So this is how the problem is is done. So it's a very straightforward solution here. All you need to do is you have to check if the price of I minus I minus 1, so the next day is greater than this, then you have to add up the profits. So you're buying on if you buy on the first, if any of them have been positive, you keep adding them, and that's how you get the solution. It's a it's pretty much very easy to identify. So you remove all the ones where you have the profit less. So in this, if I buy on the first and sell it on the second, my value is 1. I buy it on second, sell it on third, 1 1 1, or you can buy 1 and you can sell it on the fifth. So there are lots of ways of doing it. So it's a very this is a very simple solution for that. So you just do price I minus price I minus 1. If it's greater than 0, then you pretty much add that profit. If not, you just keep incrementing. So let me run this code and submit. Okay, it's been accepted. The next one is the group anagrams. So an anagram is the one which has the same set of characters in a different permutation, like eat, tea, nat, tan, and bat. So it's like you have to find all the groups. So if there are 3 groups here, so so you have to return all of them. So that's this solution. So it's a little bit longer. So the first thing that I've written is an anagram. So there are many ways of doing this. The most easy solution for me is the way I've written. If the lengths of these 2 strings are different, then it's not an anagram. You don't even have to check. If not, you haven't. If not, sort A, sort B, and just check each and every character to see if they're same. If not, if it is the same, return true, else return false. If the lengths are not the same, it's return false. So this is a simple anagram function. So I use this in the main function. So in my main function, I'm given a list of strings. So I created a map. This map is going to remember each set, the beginning characters of the each set, and this list is the list of the strings that I have here, so that I can start removing them and using them for different purposes. So here, this is the hack that I used. I assume that my input string is never going to have this character, so I assume this is to be my initial string, and then I went through this entire list of strings that I have like this, and I compared if it's any of, so if my initial string is not initialized, so right now it's not been initialized, so I took the first character of the list to be my initial string. And the next thing I've done here is I've checked if my list has this initial string. So what I did here is, if this map that I'm building for my anagram map does it have my initial string? Let's suppose does it have eat, which is my first string, let's suppose. If it is there, then my initial string is gonna be if the map has eat or something like that, then I use that. Then I try to get that new list. If it is not there, then I initialize the list. Here it's been initialized. Then I put that back into the map. So I have now the map which is empty. Now it has eat and an empty list, and I add my initial string eat into my new list. So this is just the initialization piece wherein I'm trying to find all the anagrams for that initial string. So now my eat loop is done. The next character, let's suppose after eat I have t. So here my initial string is not t, it is eat. So here I check eat and t are anagrams or not. If they are anagrams, then I add it to my eat list. I keep adding to my eat list. So let's suppose the next string that I have is I have eat t. Now I got tan. Tan is not an anagram, so pretty much I skipped tan and I go to the next. So in first iteration, I find all the anagrams of my first string that I found. So if there is eat in my first iteration, I get eat, t, 8 all together into my new list. So this loop is actually going to get everything. And once I picked up all the anagrams for this, I remove it from my main list. So my main list has all these. So now since I've done the anagram for this, each T8 will be gone. So the next string that starts off is 10. So this iteration starts off again with 10. And first iterate in this iteration in the inside loop with I start off with 10. I initialize the list, and then I find all the anagrams for 10, and I finish this loop, tan and nat. And the next one, I remove that from the main list. I just have bat. So the bat again, it goes back into this loop, and then I return the list. This is a very simple solution that I can think of, and it's in one iteration it finds all the anagrams, and then it reduces the list so that you don't have to go through it many times. So that's the and that's submit. It's been accepted. The next one is counting elements. So what this basically is, you need to find all the elements which have the next element. So pretty much if you have, so 1 has 2 as the next element, 2 has a 3 as the next element. So all the elements which has a next element. So here I have 1 and 2. So the answer is going to be how many elements like that you have in your array. So here I have 2. So in this case I have none because I don't have the next element. In this case I have 1, 2, and I can't count 3, and 1, 1. So even if there are repetitions, you just have to keep counting them. So this is pretty much straightforward. I started off with count 0. So I'm just counting all of them. I don't have to do anything. I sorted the array. That's the first step I did. And then I picked the first element, which is my start element, and the count of my previous element is 1. So what I did was the count of my previous element, what I did is, so if I'm trying to do 1, 2, 3, so let's suppose I got 1, and if I have 1, 1, my previous element is pretty much counting every time I found so every time I want to find the next element, I'm actually counting how many previous elements I have. So that is what it's doing. I initialize it to 1. So I start comparing. So is my start element the start element same as the next element in the array? So I'm just adding up. So I have ones, like if I have 10 ones in the list, I'm just adding up all of them as previous elements plus plus, and then I continue. Let's suppose I found the next consecutive element. For 1 I found 2. In this case, since that is satisfying my criteria of finding the next element, so I added how many occurrences of my previous element is into this count, and I reinitialized my previous element to 2, and my start is going to be 2 here. If I don't find a consecutive element, I reset it because I don't need to count it, and then again restart it from start is equal to array I. So pretty much what I did is I sorted the array here. So now the array is sorted. If I found 1, 1, 1 in my first iteration, I'm just adding up everything under the previous element. If I found 2, I'm adding it to my global list count, and then I reset the previous element to count how many times 2 occurs if there is a 3, and if there is no 3, it never gets added to the global list. So this is a pretty straightforward solution. I never even bothered looking at the hints. Use hash set loop. Okay, I didn't use hash set, I just sorted it because that's pretty much straightforward. Run code and submit. There you go. That's the week 1. I'll upload the week 2 very soon. Thank you.